All right, we're going to look at models for population growth today. The rate of growth of a population is directly proportional to the population. Then you get this differential equation shown here, where dp dt is the rate of growth of the population, because P is population, T is time. So rate of change of population. P would be the population over here, and then K would be the proportionality constant. So anytime you're directly proportional, you're going to get a equation that looks like this. Now that's different than if it said inversely proportional. Then your differential equation would look a little bit different. If it's inversely, that means your P would be on the bottom instead. So the difference between directly proportional and inversely proportional would look like that. Let's stick with these directly proportional ones. So what we're going to do is solve out this differential equation. This is a separable one. So we're going to separate like you've done previously now and solve this out. So I'm going to move the dt to the other side. I'm going to divide by the p. And then let's integrate this to solve. So on the left side, 1 over p, that's going to be an antiderivative of natural log of the population. On the right side here, k is a constant, and so the antiderivative of this is just kt plus constant here. All right, so now to solve this, we are going to change from log form to exponential form, which means we would get our population now equal to e to the kt plus c. We can separate that right side out. So if we separate that right side out, that's equivalent to e to the kt times e to the c, because we know when we're multiplying with exponentials, if we got two exponents with the same base, we add those together, that would be what we have right up here. All right, well, e to the c, that's just, e is a constant, c is a constant, so that's just another constant. So I'm going to instead just make this into another constant. Let's use capital C. So that means our population here is some constant times e to the k t, and that is our equation that is population growth. You've seen this before, probably written a little differently. This is just that kind of like that PERT equation that you've seen in previous classes. It's just that we're using different variables. So before we had, on the last slide, we had C here. We can use P instead. That would be P of 0, or our like initial population. T of course is time. E is that natural number, and then R, which in the last slide was our K, it's just a different letter, that's your rate. That's the rate of growth, that's your proportionality constant. So when we're using these, or when we're doing this, that differential equation where it's directly proportional, where the population is proportional to the rate of growth, that gives you this exponential growth equation.